Experiment number 3. Aim of experiment is to determine the overall heat transfer coefficient by heat exchanger using counter current flow. Requirements for these experiments are distillation flask, thermometer, condenser, short bend tubes, rubber cork, stopwatch, measuring scale, vernier caliper, etc. Reference for this experiment is a practical book of pharmaceutical engineering by Dr. Suresh Sudke, Nirali publication, first edition, page number 1.19 to 1.22. Now we will see the principle. The process of heat exchange between two fluids that are at different temperatures and separated by a solid wall occurs in many engineering applications. The device used to implement this exchange is called as heat exchangers. Here two different fluids are used, means heat is exchanged in between two different fluids, that is, say for example, gas and liquid. The flow of heat from a fluid through a solid wall to another fluid is often encountered in chemical engineering practices. Heat transfer is the movement of energy due to a temperature difference, that is temperature gradient. There are three physical mechanisms of heat transfer, that is conduction, convection, radiation. The rate of heat transfer through the fluids is determined by using the overall heat transfer coefficient. Heat transfer from one fluid at an average bulk temperature T1, say for example, it is nothing but steam, then it goes through the solid surface to second fluid, say for example in liquid, that is water, and bulk temperature is T2. Movement is because of temperature gradient, that is T1 is greater as compared to the T2. Then rate of heat transfer is determined by equation Q is equal to U into A into delta Tm. Here Q be the rate of heat transfer, U be the overall heat transfer coefficient, A be the surface area available for heating, delta Tm be the mean temperature difference. So from this equation we can find the value of U, that is overall heat transfer coefficient, and by rearranging the above equation it becomes U is equal to Q upon A into delta Tm, where heat is transferred from steam to cold water through a glass surface, that is condenser. The total amount of heat transferred is equal to either heat lost by steam or heat gained by water, and therefore we can calculate the rate of heat transfer by using the equation Q is equal to Q1 plus Q2 upon 2. Here Q1 be the heat lost by steam and Q2 be the heat gained by water. Then first of all, how to calculate the Q1, that is heat loss by steam. Equation becomes Q1 is equal to M1 into Cp1 into delta T1 plus L into M1. Here M be the mass of condensate, Cp be the specific heat of water, T1 is the temperature drop between steam and condensate, L be the latent heat of vaporization of steam. In this way we can calculate the heat lost by steam. Then heat gained by water, it is denoted with Q2, and equation is Q2 is equal to M2 into Cp2 into delta T2. Here M2 be the mass of water circulated, Cp be the specific heat of water, T2 be the temperature rise. Then flow behavior of heat exchanger. Preferably two types of flow behaviors are selected for heat exchanger. First one is called as a co-current flow. Co-current flow is also known as parallel flow, means both hot liquid and cold liquid is moving in same direction. And another type of flow is nothing but counter current flow. Counter current means one fluid is moving from left to right and another is from right to left. Means hot fluid is moving in one direction and opposite to that cold fluid is moving. This is called as a counter current flow. And another one type of flow is called as a cross flow. Means in horizontal direction hot fluid is moving and vertical direction cold fluid is moving. Then here temperature difference graph is shown in the figure. First graph is of a co-current flow, means fluid is moving from only one direction. Then at point A, difference in temperature is high, but when we reach towards point B, difference in temperature becomes low. In another case, counter current flow, at point A, we are observing the small difference as compared to the first figure, but at point B, difference is high as compared to the difference in a first figure. This is because of change in the flow behavior. And in this experiment, counter current flow is used. Then next part is a experimental setup. Assembly is the same as that of the distillation, simple distillation. It consists of a distillation flask which is filled with water and heated with suitable source of heat. Then cork is placed. In cork, thermometer is assembled to determine the temperature of steam. Flask is connected to the condenser. Condenser is arranged in such a way that cold fluid is moving in opposite direction of the steam. Then condenser is connected to the receiver tube and condensate is collected into the receiver. Next to that, procedure of today's experiment. Take all required apparatus and arrange as per setup. Generate the steam and pass through water jacket glass container. Circulate the cold water in reverse direction or opposite direction to that of the condensate of the steam. Note the temperature of steam and condensate. Note the inlet temperature and outlet temperature of water. Estimate the volume of water circulated for fixed time. Estimate the volume of condensate and measure the dimension of condenser. Calculate average rate of heat transfer and by using this value determine the overall heat transfer coefficient. Here some observations are given which we obtained after experimental work. M1 be the mass of condensate, M2 be the mass of water circulated, Cp be the specific heat of water, L be the latent heat of vaporization of steam, radius of inner tube of condenser is R, length of condenser becomes L, surface area is calculated by using equation 2 pi R into L, temperature of steam is Ts, temperature of condensate at Tc, temperature of inlet water is Twi, temperature of outlet water is Two. Then small t1 be the temperature drop between steam and water and T2 be the temperature rise. Capital T1 be the temperature difference between steam and water outlet and capital T2 be the temperature difference between condensate and water inlet. Then calculation part, as we discussed earlier, Q is calculated by considering the three parameters: overall heat transfer coefficient, surface area of heating and average temperature difference. Then by rearranging the equation, then U is equal to Q upon A into delta Tm. Then Q is calculated by considering the two parameters, that is heat lost by steam and heat gained by water. Therefore equation becomes Q is equal to Q1 plus Q2 upon 2. Then Q1 is calculated by considering the parameters, that is mass of steam, then specific heat of water, temperature drop between steam and condensate, and latent heat of vaporization. By putting the values into the equation, the Q1 is equal to 6000 calories. Then second part, here latent heat of vaporization is 540 calories and specific heat of water is 1 calorie per angstrom. Next to that, calculation of heat gained by water. Q2 is equal to M2 into S2 into T2. M2 be the mass of water circulated, S2 be the specific heat of water, T2 be the temperature rise. And by putting the values, the Q2 becomes 16,000 calories. Then average of these two values is 11,000 calories. Then second parameter, that is temperature drop, mean temperature drop. Then equation for delta Tm is equal to delta T1 minus delta T2 upon 2.303 into log into bracket delta T1 upon T2. Then delta T1 is nothing but the difference in between temperature of steam and temperature of water outlet. Temperature of steam is 100 and of water outlet temperature is 34. Therefore, delta T1 becomes 66. Delta T2 is nothing but the difference in between temperature of condensate and temperature of water inlet, and value of delta T2 is equal to 14 degrees Celsius. Then by putting the values into the equation, delta Tm becomes 33.76 degrees Celsius. Then next parameter, that is determination of surface area, equation becomes A is equal to 2 pi RL. R with the radius of tube, it becomes 0.4 centimeter. Length of tube becomes 25 centimeter. By putting the values, A becomes 62.8 centimeter square. And finally, we will determine the overall heat transfer coefficient by putting the calculated values into the equation. Then U is equal to 11,000 upon 62.8 into 33.76. Answer becomes 5.18 calorie per centimeter square into degree Celsius. Then result becomes the overall heat transfer coefficient for a heat exchanger using counter current flow is found to be 5.18 calorie per centimeter square into degree Celsius. Thank you.